In a recent poll, 520 people were asked if they liked dogs, and 18% said they did. Find the margin of error of this poll at the 99% confidence level. Give your answer to 3 decimals. All right, so what we're looking for here is the margin of error. So be careful, we're not trying to get the entire confidence interval here. So the margin of error, it is found with the formula z sub c times the square root of p hat times q hat divided by n. Now, we already have some information readily available to us. We have n, which is given in the problem as 520. P hat, which is the proportion out of the sample that favor our event, and 18% said they liked dogs, so 18% of the sample, so that is the proportion. So p hat is 0.18. Q, P and Q are always related as complements. So Q is just whatever 1 minus P is, so 1 minus 0.18 or 0.82. And then we need to come up with the value of z sub c. So z sub c, this is a critical value based off of the given level of confidence. And we were asked to use a 99% confidence level. So that means the level of confidence is 0.99. In order to convert a level of confidence into a critical value, we have a formula, which is the absolute value of the inverse norm of 1 minus c divided by 2. And whatever technology you're using for inverse norm calculations is fine. We should all get the same result either way. So I am using the TI calculator here, and if I start off finding this part right here, this 1 minus c divided by 2, I can get that by doing 1 minus the level of confidence is 0.99, so 1 minus c, and then dividing that by 2. And I did that in 2 steps on purpose. I could have done it in a single step on the calculator, but I would have needed to put parentheses around the numerator to prevent the order of operations from giving me a wrong answer. So now what I need to do here is find the absolute value of the inverse norm of 0.005. All right, so using the calculator, I'm going to hit second and vars, which brings up my distributions menu. The third item down for me is inverse norm, and it can take up to 3 inputs. If you have the stat wizards turned on, you're seeing this menu like I have here, but if it's not turned on, that's fine. You just type in 0.005 and press enter. All right, so the mean and standard deviation are 0 and 1 respectively because I'm using a standard normal distribution. So just paste that onto the home screen and press enter. So negative 2.576, and we're going to do the absolute value of that. So I'll make it 2.576. Just give an extra decimal there for rounding errors here. Now, margin of error. I've got everything I need to get my margin of error. I'm going to take 2.576 times the square root of, so p hat is 0.18, q hat is 0.82, and n is the value 520. So I can put this all into my calculator and get the answer here. So 2.576 times the square root of 0.18 times 0.82 divided by 520. You don't have to worry about parentheses under that square root. And we get 0.043. So there is the margin of error. Now, If you're not the type that wants to remember formulas, there's an alternate way of doing that. You could do it entirely on the calculator. If you come up with the confidence interval, so if you hit stat, go over to tests, and then down to 1 prop zn. Come up with your confidence interval. So for instance, X is the number of items that favor your event. So you're given only the percent of items that favor your event. So take 0.18 times 520 to change that to a number. And you do need to round this because the calculator doesn't care much for non-integer values in that situation. And level of confidence, 0.99, calculate. So that gives the endpoints of the confidence interval. So if you want to find the margin of error, what you can do is the endpoints of your confidence interval, so surround the value p hat. So we have the endpoints of the confidence interval as 0.137, and the upper one was 0.224. So if you find the midpoint of those two values, or actually let's just find the distance across. So 0.224 minus 0.137, so 0.87, or 0.87 that is the distance all the way across that interval. If you divide that by 2, then that's going to give you half of the distance across. And so half that distance, there's a rounding issue here. We only did 3 decimal places with this z-score down here, and that's probably where it comes from. But you can see that it's basically the same value, so 0.043.